Hey everybody, okay, so now we're just kind of pulling everything together into this one section. You're not going to learn anything new in this section, so it's just more practice and maybe just different ways to look at how to factor, especially things with big numbers. You're hoping that there's a trick to it, I guess. So let's take a look at some of these.
All right, so this page is just kind of a cheat sheet, something that you could refer back to, but it really should not be brand new information. So if you have a binomial, remember a binomial means two terms, and you have a difference of squares, then that factors to be the conjugate pair that we've talked about. If you have a sum of squares, which looks like this, that does not factor. It's prime. It just, oh, sorry, it looks like that. There we go. That does not factor. It is prime. All right, if you have a sum of cubes and difference of cubes, we actually did not learn these in this class. But I just left this on this because it was already on the page. But it does factor. So if you have a sum of cubes, that does factor to be something like this. And a difference of cubes factors to be something very similar, just minus signs in weird places. All right, so if you have a trinomial, we talked a little bit about the guess and test method. That's what this is. And if you have something that looks like this, I talked to you a little bit about possibly taking a look at this term and saying, could we take the square root of that? And if you can, then it might turn into something that looks like this. Same thing with this one, but the minus sign. Notice the plus here and that, and then the minus and that. All right. The AC method is what we mostly did in this class. If you have more than 3 terms, then you're going to factor by grouping. All right, so this is sort of a how-to page if you need this. I hope you've had enough practice that you really don't need this at this point. But at this point, I'm not going to read it to you, so you might want to hit pause if it's something you do want to read through. It may or may not be helpful to you. I left it in here because some people might prefer this. So anyways, hit pause and read through it if it's something you're interested in. Otherwise, just skip on past. All right, let's start with this example. Okay, so we're going to take a look at each of these terms and we're going to ask ourselves, what do they have in common that I can factor out? And they both have a 4 in common, and they both have at least 4 x's. Now remember, I can't take 5 x's out of this one, okay? So that's why I have to go for the 4 here. All right, so now what times 4x to the 4th would give me 4x to the 5th? Well, that would just be plain old x, because all I need is one more x. And what times 4x to the 4th would give me a positive 12x to the 4th? And that is a positive 3. And right now, this is as good as this factoring gets. We can't do anything else to it.
All right, so for this problem, let's just use our AC method, which means we take our leading coefficient times our constant term. So 12 times 2 is 24. I'm writing it off to the side. I want factors of 24 that add up to be negative 11. Sometimes these jump out at me and then sometimes they don't. But keep in mind that if the two numbers multiply to be a positive, but they add up to be a negative, that means both of them have to be negative. Those don't work. Those don't work. There we go, we found it now. So what we're going to do is we're going to rewrite our middle term using negative 3 and negative 8. So first term just gets rewritten. Middle term gets rewritten as negative 3 and negative 8x. Negative 3x and negative 8x. Okay, so now we're going to factor by grouping. And what can I factor out of 12x squared minus 3x? I can factor out a 3x. What times 3x would give me 12x squared? Well, that's a 4x. And then what times 3x would give me a negative 3x? And that's a minus 1. And if this right here is a minus, you bring down a minus. If it's a plus, you bring down a plus. So it's a minus. We're going to factor out a negative something or other. What do these two terms have in common to factor out? They have a 2. So let's factor out the negative 2. What times negative 2 would give you a negative 8x, and that is a positive 4x? And what times negative 2 would give you a positive 2? Well, that's a negative 1. Okay, this has to match this perfectly in order for you to go to the next step. So the next step, we're going to factor out our 4x minus 1, and what's left is 3x minus 2. All right, we just factored it. All right, for this one, let's factor out our common factor, our GCF first, and notice how they both have G's, okay? So this one has 3, but this one only has 1. So I can't take 3 G's out of this one. I can only take 1 G out of both, okay? So we're going to factor out G, and what times G would give me G cubed, and that is G squared. And what times G would give me 25G, and that is plus 25. And honestly, that's as far as we can go. This right here is prime. A sum of squares is prime, always, okay? So this thing is factorable because we were able to change the way the original problem looked. But once we got to this place, there's nothing else we can do. So this right here is as good as this answer gets. All right, so again, we're going to factor out our common factor, our GCF. And what do these two terms have in common? They've got at least a 3 in common, right? So let's factor out a 3. What times 3 would give you 12y squared? Well, that is 4y squared. And what times 3 would give you a minus 75? And that is minus 25. All right, now here's what I want you to notice. This and this are both perfect squares, okay? So this is a perfect square and this is a perfect square. And it's a difference. And so when you have a difference of squares, that factors to be a conjugate pair. Now this 3 still has to sit out front the whole time, okay? It's never going to go away. So we've got to write the 3. And then what we're going to put in here is the square root of this, which is 2y, put that there and there. The square root of this, which is, and one's a plus and one's a minus. This is just a shortcut. Now, could you still do the AC method? Yeah, and you would want your middle term to be 0. So you can still do the AC method like I taught you. It's just more work. It's so much faster if you can recognize that this is a difference of squares and it factors to be a conjugate pair. All right, so this is one of those that if you don't recognize right away that this is a perfect square and this is a perfect square, you could still do the AC method and you would still come up with a good answer. You would come up with a great answer, in fact. So, but if you recognize that this is a perfect square and this is a perfect square, then it might be helpful to try. You still have to check your work because it doesn't always work out like this, but it might be a good idea to try to do this. Take the square root of this and put it here and here. Take the square root of this and put it here and here. And since your middle term is minus, but it multiplies to be a positive, they're both going to be minuses. And what you want to do is you want to check your work. So I'm going to check my work in red, okay? So 2a times 2a is 4a squared. 2a times negative 3b is negative 6. Oops, I forgot my a. b. And then negative 3b times 2a is negative 6ab, and then negative 3b times negative 3b is a positive 9b squared. Combine our like terms, we get 4a squared minus 12ab plus 9b squared. And look, it works, okay? So I know for sure that this is the factored form. Now, a shorter way to write it, because they're the exact same, would be like this. There we go, and we're done. But don't forget, the key to doing this shortcut is making sure that you check your work. So make sure you check your work. All right, so for this problem, we can factor out a common term. It looks like they all have a 6 in common. So let's factor out our GCF of 6, and we get y squared minus 3y minus 10. Okay, now let's try to factor this polynomial. All right, so we want factors of negative 10 that add up to be negative 3. Ooh, let's see here. Negative 10 that add up to be negative 3. So how about 2 and negative 5? All right, now remember, this 6 stays out front, okay? So we're kind of ignoring the 6, but it is there, okay? But when your leading coefficient is 1, you don't have to go through that whole rigmarole of rewriting your middle term. When it's 1, then you can just rewrite your factors using these terms. So what I mean by that is we could just write this as y plus 2 and y minus 5. Okay? And we're done. All right? So again, when that leading number is 1, and you found the factors that multiply to be that, but add up to be that, then you're done. You can actually skip that middle couple of steps, which makes our life a little bit easier. All right, I kept this example in here for a reason. Again, I didn't teach you the sum or the square of, I'm sorry, the sum of cubes or the difference of cubes, because that will be taught in another class. Now, this textbook actually does teach you that, but as this problem stands, this is not a sum of cubes, okay? But what we end up with is, okay? So let's go ahead and factor out the 3. So I've got 3, and then what's left over is 8x cubed plus, let's see here, all right, and now this is a sum of cubes, and it does factor further. Again, in this class, I am not going to ask you to go past this, but just so you know, in a future class, this will factor further, okay? But for right now, I'm okay with you guys leaving your answers like this.
Okay, now for this problem, let's factor out a 2 from both of these. So let's see here. We've got 2, and then what times 2 would give us 2x to the 4th? That's x to the 4th. And then what times 2 would give us negative 32? That's minus 16. And now we can factor this. This is a perfect square, and this is a perfect square, and this is a difference. So a difference of squares factors to be, don't forget the 2 out front. Okay, now this is a sum of squares, so that's not factorable, but this actually is factorable again. So let's try that. So we've got, and then this becomes x minus 2, x plus 2, and this didn't factor, so I'm just rewriting it. Now it's fully factored. What a mess. All right, for this one, we've got 4 terms. So let's factor by grouping. So let's factor those 2 and then factor those 2. Okay, whenever we factor these 2, what do they have in common? They've got a 3 and an x in common. And then that leaves us with x plus, let's see here, 2b. And then we're going to bring down the minus. And then these guys have in common a 3 and an a. And so then we're left with x plus 2b. All right, so those match. That's good. Let's see here. So now we have x plus 2b. We're going to factor that out. And what are we left with? We're left with 3x minus 3a. Now, here's the thing that I failed to do, and I'm kind of glad I failed to do this, because I want to show you that in the very beginning, I should have factored the greatest common factor out of all four of these terms, but I didn't, okay? And so what that means is that if you don't factor out a greatest common factor in the beginning, you're going to end up with something that could be factored more. So look at this. This doesn't have anything that can be factored out. But look, this one has a 3 that can be factored out, okay? So that's what will happen if you fail to factor out your greatest common factor in the beginning. You'll be left with a factor that could be factored further, okay? So we've got our x plus 2b here. I'm going to factor out my 3, and then I'm left with x minus a. But this could be written as 3 in the front. That's the proper way to write it. X plus 2b, and then x minus a. And this is fully factored. All right, for this one, it looks like we can factor out a 2. So let's do that. So we've got factoring out our 2. We're left with 5x squared minus 17x minus 12. Now let's multiply the 5 and the negative 12, and we get negative 60. And so let's write down our factors and see if we can find a pair of factors that adds up to be negative 17. So we know that our bigger number is going to be negative because our middle term is negative. So let's see here. 1, negative 60, 2, negative 30, nope. 3, negative 20, there we go. We found it. So it's this one right here. All right. So let's rewrite our middle term using 3 and negative 20. So the 2, again, just following us along, the 5x squared, I'm just rewriting. Now, this is what I'm rewriting into these terms. Okay, and now I'm going to factor this by grouping. And let's see here. What can we factor out of these two pieces? It looks like an x. And that would leave us with 5x plus 3. And now out of these, I'm going to bring down my minus. I can factor out a 4, which leaves us with 5x plus 3. By the way, I put 2 parentheses here because this one goes with this one out front. All right, so now we're going to, the 2 stays out front. I'm going to factor out my 5x plus 3, and I'm left with x minus 4. There we go. All right, that's it for this video. Let me know if you have any questions, and have a great day.